Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin.
In the beginning there was almost nothing, just a quiet hum beneath silence, a shiver in the void. And then, the spark. The universe unfolded like a flower blooming in eternal slow motion. Light scattered like pollen, dust curled into galaxies, and stars began to sing. Among the earliest travelers of that great unfolding were the neutrinos. They were born in the heart of stars, in the breath between explosions, in the moment when matter decided to become something more. Neutrinos are tiny. So tiny, in fact, they pass through almost everything without leaving a trace. They slip through planets, through mountains, through your own body, millions of them every second, and you never feel them. They are the ghost notes of the universe's music. But just because they are quiet does not mean they are not important. Their journey is ancient, their path nearly unhindered. From the core of a dying star, a neutrino may travel billions of years, passing galaxies and cosmic winds, drifting softly on invisible trails. They do not glow, they do not shout, but they are there, always moving, always dreaming. Imagine a single neutrino, born in a supernova 10 billion years ago. The star exploded in a glorious death, scattering elements and memory across the cosmos. In that moment of brilliant collapse, a neutrino was born light as a whisper, free as a wish. It slipped away at nearly the speed of light, leaving behind the roar of the explosion, the birth of black holes and nebulae, the chaos of change. It traveled alone, silent and untouchable, never looking back. And here's the wonder, that same neutrino might be passing through you right now. It carries no charge, it has almost no mass. It does not notice you and you do not notice it, yet it has touched stars. It has tasted the breath of creation. It has moved farther than any wind, faster than any tide. It has no memory, but if it did, oh, what stories it could tell. Some scientists call neutrinos ghost particles, but that feels too lonely. Maybe they are more like stardust messengers, quiet couriers of cosmic moments. They are not bound by walls or air or even time in the same way we are. While we walk on Earth's surface, pulled by gravity, touched by weather, they continue on endlessly. To study a neutrino, we must go underground. Deep beneath mountains or buried under Antarctic ice, scientists build delicate instruments to catch just a whisper of their passing. These labs are like still ponds hoping to feel the ripple of a single drop. And sometimes they do. A single blue flash, a soft trace in water, a tiny echo of a vast journey. It is hard to imagine something so important could be so small, but the universe often hides its secrets in quiet places. Neutrinos are messengers of nuclear fires, keepers of stellar truth. They tell us about the inside of stars, about what happened in the first seconds of time. They arrive from explosions we cannot see, from corners of space we have not mapped. And still they come. Millions, billions, a wind made of particles flowing through everything. As you lie still in the hush of night, imagine them moving. Not in straight lines, not like arrows, but like dancers in a great unseen ballet, moving through you and beyond you, through oceans, through stone, through dreams. Every second, a silent flood of ancient travelers brushing past the edges of your being. And now let's drift deeper into the space where they are born, into the heat and pressure and wonder of the stars themselves. Let's follow a neutrino backward, into the fire that first called it into being. Let's feel the music of atoms as they change shape, and hear the soft hum of fusion lighting up the dark. Now imagine the heart of a star, not the glowing surface we see from far away, but the center, where pressure is so great it squeezes atoms together like the embrace of time itself. Here hydrogen becomes helium, and in that transformation light is born, not just the warm light that reaches our eyes, but something deeper, something older. This is where neutrinos are made. Inside the star, every second countless reactions unfold. Nuclei merge, shift, change. And with each change, a neutrino is quietly released like a sigh from the core. The neutrino doesn't stay. It doesn't linger in the roaring heat. It slips through the dense layers of plasma and iron, through layers so thick that light itself takes thousands of years to crawl through. But the neutrino, it escapes in moments. It carries with it a whisper of the star's truth, not what it looks like, but what it is. These particles are not witnesses. They are essence. They are the product of stars telling the universe what they are made of, who they are inside. And when we learn to listen to these neutrinos, we are, in a way, reading the secret letters stars have written to the cosmos. When a star dies in a supernova, something remarkable happens. In less than a second, a colossal amount. Of energy is released. Light bursts out, yes, gas and dust rush into space, but most of the energy, more than 99%, is carried away by neutrinos. They fly in every direction, faster than fire, faster than fear. A storm of them, unseen but vast. Some of these neutrinos reach us. Even now, Earth is bathed in their passing, not just from our sun, which sends a steady stream every moment, but from ancient events far across the sky. Supernova neutrinos, cooling neutron stars, and perhaps even the quiet echo from the Big Bang itself, all flow through us, like a wind beneath reality. In Japan, under a mountain, a vast underground tank filled with ultrapure water waits silently. It is dark still, a pool of dreaming clarity, and then now and then it sees something, a flash, a ripple, a blue glow that lasts just a moment. That light is the footprint of a neutrino, the trace of a traveler who has come across galaxies to be seen for just an instant. To watch neutrinos is to look backward in time. Some have traveled longer than any memory on Earth. They were born when there were no trees, no oceans, no stars like ours. Only the first fires, the raw breath of the universe's beginning. When one of those particles touches our detectors, it is as if the past has reached out to tap our shoulder. And yet they are still so gentle. A neutrino does not tear or burn. It does not force its way in. It passes through, leaving only the softest trace. It reminds us that not all power comes from pressure, that not all messengers speak with thunder. Our own bodies are full of atoms born in stars, carbon, calcium, iron. These were shaped in stellar furnaces cast out by dying suns. But the neutrinos that once slipped away from those same stars, they are still moving. Some passed through our ancestors, some passed through us. They have seen the evolution of galaxies, the dance of black holes, the building of life, yet they remain as light and quiet as they began. Some scientists believe there may be more than just 3 types of neutrinos. They call them flavors: electron, muon, and tau, and perhaps more that we haven't found yet. Even stranger, these flavors can change. A neutrino born as one type may arrive as another. It's as though it changes its identity while traveling, a shapeshifter among particles. This mystery of transformation is still not fully understood, but it hints at something deeper, that even the smallest things contain worlds of complexity. When you close your eyes at night and feel the stillness around you, you are never truly alone, not in the atomic sense. The world is full of movement you do not see. Beneath your skin, blood flows, neurons fire. Outside, the air is alive with molecules, and deeper still, below the noise of all that, neutrinos flow. They pass through the mountains and through the seas. They glide beneath cities and across deserts. They do not age, they do not slow, they do not need anything. In that way, they are perhaps the purest form of freedom. Untouched, unclaimed, forever in motion. You can almost feel their presence now, not directly, but as a sensation just beyond awareness. A cosmic breath, a shimmer in the deep. And though they cannot speak, they are always telling a story. Not in words, but in motion. Not in sound, but in silence. So next time you see a star, think of the neutrinos. Not the ones you see, but the ones you feel. The ones that have traveled across the dark to pass through you, unnoticed and yet eternal. They are the sky's quiet poetry, the particles of dreaming. Let us drift now toward the edge of this journey, toward the moment when the neutrino's long travel touches something new, toward the questions of where it ends, or if it ever does. Let's imagine the final quiet of a particle that never rests, and wonder what it means for us to live in a universe where even silence has a story. There is a kind of peace in knowing that some things never stop moving. Neutrinos, born in fire, drifting through cold, slipping through everything we know, are among those quiet, ceaseless wanderers. While the stars pulse and galaxies turn, while lives begin and end, the neutrinos continue. They do not rest, not in the way we understand rest. They do not sleep. But their journey carries a softness, a quiet persistence, like the hush between waves or the stretch of shadow at twilight. As we try to understand these particles, to trace their path, to measure their mass, to guess their origins, we are really doing something more. We are looking at the invisible threads that tie the universe together, threads made not of force, but of presence. The neutrino is a reminder that much of the cosmos is shaped not by what is loud or bright, but by what simply is. Somewhere far from us, a supernova is unfolding. A star that has burned for billions of years has reached the end of its light. Its center collapses, and in less than a second it becomes something else, a blah. CK hole perhaps, or a neutron star, spinning and dense. In that final breath, before light can even escape, the neutrinos leave. They are the first messengers of change. They outrun the light. They carry the signal that the old star is gone and something new is being born. We are now building telescopes not for light but for neutrinos. giant observatories buried in ice, in stone, in still water. We are teaching ourselves to listen in new ways, to see with different eyes. It is not easy. The neutrino does not speak loudly, but the universe rewards patience. In waiting, in watching, we are beginning to hear their language, and it is beautiful. In Antarctica, under more than a kilometer of clear blue ice, a telescope named IceCube waits. Its sensors stretch like constellations in frozen crystal, hoping for that one small flash. When it happens, the light is not random. It carries direction, energy, even memory. It tells us where the neutrino came from, perhaps a black hole devouring a star, perhaps the edge of a galaxy we've never named. That flash, so brief, so faint, is a whisper across time. And yet, it means everything. Neutrinos remind us that presence does not require power. That influence does not require touch. We live in a universe where tiny, almost invisible things shape great truths. Gravity curves space. A photon travels forever until caught. And the neutrino, that softest of particles, connects the past to the present, the deep to the near, the stars to our skin. Perhaps the most mysterious question is whether neutrinos hold the key to why anything exists at all. Some physicists wonder if, long ago, in the earliest instance after the Big Bang, a difference between matter and antimatter allowed the universe to grow. And perhaps neutrinos played a role in that difference. Perhaps their silence held the first decision, the quiet that tipped the scales toward something, rather than nothing. We don't know, not yet. But even in the not knowing, there is beauty. The neutrino shows us how to wonder with gentleness, how to explore not by force but by attention, how to be curious without conquest. And so we watch, we build more detectors. We bury them deep in mines and oceans. We cool them with liquid argon and fill them with pure water. We do all of this just to catch a whisper, to feel, for a moment, the path of a particle that might have come from the first breath of time. When you walk at night beneath the stars, let yourself feel it, the gentle tide of particles flowing through you. Not just neutrinos from the sun, but from every corner of the universe. They do not see borders. They do not stop for walls. They are the purest travelers, the ones who go everywhere without leaving harm behind. You too are part of their path, not because they choose you, but because they pass through all things. You share space with stardust, with magnetic winds, with ancient fire, and with every neutrino you are reminded, even the smallest motion can be infinite. So let us rest here in this knowledge. Let us breathe in the rhythm of the cosmos, soft and slow. There are particles moving through you now that were born before Earth was made. They carry no message you can read, no sound you can hear, but they carry presence, a quiet promise, a rhythm older than light. The neutrino does not need to arrive. It is always arriving. It does not need to stay. It is always moving. And in that endless journey there is a kind of peace, not the peace of stillness, but the peace of being part of something vast and soft and eternal. This is the neutrino's dreamy journey, not in bursts but in waves, not in noise but in motion, a cosmic lullaby written in silence sung across the stars. And as we listen, softly, slowly, patiently, we begin to understand that the universe does not always speak with thunder. Sometimes it whispers. Sometimes it dances. Sometimes it simply passes through. At the farthest edge of everything we know, where galaxies grow thin and time stretches like silk, there is a kind of quiet that defies description. Not silence exactly, but a hum so soft, so ancient, that it feels like the memory of sound. Scientists call it the cosmic microwave background, but that name does not carry the poetry it deserves. What it truly is a whisper from the universe's first breath, a glow that has never gone out. Imagine standing in the dark, not night dark, but a deeper dark, the kind that existed before stars. And then imagine a flicker, not of light as we know it, but of warmth spread across space like a soft blanket. That warmth is still here. It surrounds us. It fills the sky. We cannot see it with our eyes, but with special instruments we can feel it. A faint wash of heat, stretched thin by billions of years, the echo of creation itself. Long ago, before galaxies, before atoms even had a chance to form, the universe was a hot, glowing soup. Particles swirled in all directions. Colliding and bouncing, a chaotic dance of beginnings. It was not peaceful, not yet, but it was full of potential. In this dense, bright fog, light could not travel far. Photons were trapped, scattered endlessly by the charged particles all around them. There was no clear direction, no stars, no planets, just energy and possibility. But as the universe expanded, it cooled. Slowly, gently, the temperature dropped, and with that cooling came clarity. After nearly 380,000 years, the fog lifted. Electrons settled into place around nuclei. Atoms were born, and in that moment light was set free. It traveled outward in all directions, a wave that never stopped. That ancient light, stretched and softened by time, is what we now call the cosmic microwave background. It is the baby picture of the universe, still glowing, still moving, still speaking in its own quiet way. This whisper of warmth reaches every corner of the cosmos. No matter where you look, it is there, even between the stars, even in the blackest spaces. It has no direction, no beginning point you can point toward. It comes from everywhere at once, like a memory so deep it has no edges. To measure this light, scientists have built satellites and detectors sensitive enough to catch a signal less than 3 degrees above absolute zero. That's colder than any place on Earth, colder than dry ice, colder than space itself. And yet the signal is still there, gentle, steady, ancient. In 1965, two scientists, Arno Penzias and Robert Wilson, accidentally stumbled upon this sound. They were working on a large antenna trying to measure radio waves from the Milky Way when they found a persistent noise. It was not from their equipment. It was not from the Earth. No matter where they pointed the antenna, the noise remained. That faint hiss was the cosmic background, the afterglow of the Big Bang still singing through space. Since then, we have studied this glow in ever greater detail. We've mapped it, pixel by pixel, and discovered tiny variations, hot spots and cold spots, just a fraction of a degree apart. These differences are important. They tell us where matter was slightly denser, where gravity began to shape clouds of gas, where galaxies would one day grow. In these faint fluctuations lie the seeds of everything, of stars, of planets, of life. The whisper is not uniform. It is textured like the grain of ancient wood or the quiet patterns of sand in a windless desert. In those textures, we read the story of birth and growth and endless change, and yet it is still so soft. You could walk your whole life under this glow and never feel it, but it is there, brushing past your skin, through your breath, around your bones, a warmth that is older than memory. Some describe the background radiation as a fossil, but fossils are hard, fixed, silent. This glow is still in motion. It still travels. It still arrives. It is not trapped in rock but carried in space. It is a living whisper, a breath that has never ended. And just like a whisper, you must listen carefully to hear it. Every star we see, every galaxy, every drifting atom, all of it is layered over this ancient light. It is the backdrop to all things, the quiet canvas on which the universe paints its stories. We forget it's there because it is everywhere. But if you peel back the galaxies, quiet the noise, look deeply into the black, what you find is not emptiness. It is a soft glow, still unfolding, still telling us where we came from. So let us sit with this whisper. Let us imagine what it saw, a universe with no stars, only fire and change. Let us feel its warmth, not with skin, but with wonder. Because every moment you live, every breath you take, carries within it a trace of that first light, not as something separate, but as something deeply, quietly shared. And now let's drift into the details, into the places where temperature meets time, where photons stretch like old lullabies, and where the soft variations of that glow reveal the shape of everything to come. Let's listen more closely to the quiet, and see what it has to teach us about being, about becoming, about belonging to a universe that never stops whispering. Let us now listen more carefully to the texture of that ancient glow, the soft radiation that flows across the universe like a sigh too old to forget. Each point in the sky where this whisper reaches holds a slightly different temperature, a tiny fluctuation in warmth that speaks of places long gone. These differences are unimaginably small, just millionths of a degree, yet they are the fingerprints of all that was to come. From them, galaxies would swell into spirals, stars would ignite, and life would, one day, open its eyes. The cosmic microwave background, or CMB as scientists call it, is not merely a light stretched across time. It is a woven story, a pattern frozen in expansion. As the early universe cooled and began to settle, small ripples in density began to shape the future. Where there was slightly more matter, gravity pulled it tighter. Where there was slightly less, it thinned into the quiet of space. These small differences, recorded in the light of the CMB, are the foundation of the cosmic web, the great lattice of galaxies, stars, and voids that now span billions of light years. Imagine those early ripples as the soft waves on a newborn ocean, a surface still finding its shape. Over billions of years, those waves hardened into structure, forming the scaffolding of the universe. When we study the CMB, we are not just looking into the past. We are tracing the veins and rivers that guided the flow of matter through time. We are seeing the hidden hands that shaped the sky. And all of this is written in light, not bright, burning light, but a gentle, low-energy glow. This glow has been stretched by time itself. As the universe expanded, the wavelength of the light expanded too. What was once a searing blaze is now a cool whisper, cooled from thousands of degrees to just above absolute zero. It is as if the heat of creation has been lulled into a murmur, still present, but calmed. When we listen to the CMB, we are not listening to noise. We are listening to order that once lived inside chaos. Scientists use delicate instruments aboard satellites like COBE, WMAP, and Planck to study this whisper. These space telescopes gaze out into the quiet with incredible sensitivity, mapping the sky with care, collecting the softest messages sent across billions of years. The maps they create are not like star charts or planetary images. They are more abstract, swirling clouds of faint color, deep blue and warm orange. These colors don't represent visible light but temperature differences. Every swirl is a clue, every patch a puzzle piece. From these maps, we learn how fast the universe is expanding, how much dark matter and dark energy it holds, and how everything we know came to be. There is something tender about this process, to wait for the faintest signals, to peer so deeply into the dark that you begin to see the story beneath it. It reminds us that truth does not always shout, that sometimes the deepest answers come not in storms but in stillness. These variations in the CMB are not just lines in a graph. They are echoes of pressure waves like sound, but sound that moved through the plasma of the early universe. Long before music, before birds, before wind through leaves, the cosmos was singing in its own way. These ancient oscillations, called acoustic peaks, are still recorded in the light. Each peak tells us something about the shape of space, about the curvature of time, about the way matter bends under its own memory. And in this light we find a strange harmony. The universe, even in its wildest beginnings, was balanced. Too much matter and it would have collapsed. Too little and it would have thinned into nothing. But somehow it found the middle, the golden breath between fire and silence, the whisper that became everything. We are not separate from this whisper. We are made of it. The atoms in your hands were once part of the clouds shaped by those early fluctuations. The carbon in your breath, the calcium in your bones, the iron in your blood, all of it followed the map written in the CMB. You are not just walking beneath the sky. You are walking within its story. Sometimes it is easy to forget this. The world feels heavy. Life moves fast. But beyond the noise of cities and clocks, beyond the pull of gravity and time, there is still that ancient light. It passes through you gently, as it always has. You don't need to reach for it. It is already here. Close your eyes and feel it, not as warmth, but as memory. The quiet memory of everything that has ever been. That glow, stretched over billions of years, still holds the shape of you, of stars, of silence becoming song. And as we rest in this understanding, let us prepare to look further still. Let us step beyond the glow, into the deep black that followed. Let us explore how galaxies began to form in the quiet spaces between the waves. Let us listen to how the first stars kindled their light in the soft echo of this ancient warmth. Let us drift into the beginning of the cosmos as we know it, and see how whispers turned into worlds. Now let us drift further, past the soft light of the cosmic background, into the quiet spaces where that whisper began to form shapes. As the early glow of the universe stretched and cooled, it left behind tiny ripples in density, small hills and valleys of matter. In those deeper valleys, gravity began its gentle work. It pulled hydrogen together, the lightest and most abundant element, born just minutes after the Big Bang. These gatherings were quiet at first, thin clouds of gas floating in the silence, but slowly they grew. Over millions of years, these clouds thickened. They began to spin, pulled by invisible fingers, as they spun. They pressed inward, and as they pressed, they heated. When the center of such a cloud became hot enough, a miracle happened. Nuclear fusion began. Hydrogen atoms merged into helium, releasing light and energy. A star was born. The first stars were giants, many times larger than our sun, burning hot and fast. They lit up the darkness for the first time, turning the quiet sea of the early universe into a place of light and shadow. And still, behind them, the whisper remained. The cosmic background did not fade. It stretched thinner, yes. It cooled further, but it was never gone. It became the backdrop for every flicker of starlight, the stage for galaxies, for planets, for life. It was the silence beneath the song, and through that silence, the structures of the universe began to unfold. Galaxies formed where matter was thickest, swirling spirals of dust and stars, held together by gravity and time. Between them stretched vast emptiness, cold and quiet, where only a few atoms might drift for miles. But even there, the whisper lingered, faint but present, like a memory that never fades. Some galaxies collided, some spun apart. Some gave rise to systems of planets like seeds around a flower. On one small planet circling an average star, that same background glow still washed down every night. And on that planet life emerged, cells divided, creatures evolved, eyes opened to the sky, and eventually minds began to wonder where it all came from. That wonder led to questions. The questions led to tools, telescopes, satellites, equations, theories, And those tools in time led us back to the whisper, to the realization that everything we see, the stars, the oceans, even our own breath, was shaped by the softest of differences in an ancient light. The beauty of the cosmic microwave background is not just in what it shows us, it's in what it reminds us that great things begin quietly, that the smallest changes can become galaxies, that the universe in its earliest form already contained the story of everything, not written in noise but in balance, in harmony. Scientists continue to listen. New instruments are being built to map the CMB in even finer detail, to study the polarization of its light, to search for signs of inflation, the period when the universe expanded faster than light itself. Some hope to find the echo of gravitational waves, ripples in spacetime from the first moments of existence. These ripples would be woven into the background's fabric, like hidden verses in an ancient song. We are still learning how to hear them. And all the while, the whisper continues, not just in deep space but here with us. It moves through our world in silence. It does not push or pull. It does not burn or freeze, but it connects. It links us to the moment when time began, to the unfolding of space, to the breath of light that never stopped breathing. There is something comforting in this, in a universe so vast, so unknowable, to find a thread that runs through all things, a thread that asks nothing of us but wonder, a thread that reminds us we are not separate from the cosmos but shaped by it, formed in it, held gently within its light. So let this whisper stay with you. Let it hum beneath your thoughts as you walk through your days. Let it curl into your sleep as you drift into dreams, for it is not just a relic of the past. It is a presence, a lullaby written in temperature and time. And perhaps that is the secret it carries, that beneath all the change, all the motion, all the distance, there is a softness that remains. A voice without sound, a presence without weight, a whisper that once filled everything and still does. So rest now in the arms of the ancient light. Close your eyes and know that it is all around you, soft as dusk, endless as sky. It does not ask to be seen. It only is, it only continues. As you breathe, it moves through you. As you sleep, it watches over you. As you dream, it holds the memory of everything that ever was. This is the whisper from the edge of time, not loud, not urgent. Just forever. Between the great glowing cities of stars, across the dark seas of cosmic space, there is a stillness so deep it feels untouched by time. These are the intergalactic spaces, vast, quiet realms that stretch between galaxies, where light travels for eons and almost nothing stirs. It is here in this silence that the universe holds its breath. Most of what we see when we look at the sky, the pinpricks of stars, the soft swirls of galaxies, the faint haze of nebulae, all of it lies within islands of gravity, clumps of matter held tightly together. But between these islands, between the Milky Way and Andromeda, between clusters and superclusters, there are oceans of space that seem almost empty. They are not lifeless, not forgotten, but they are quiet. Here the light is sparse, the atoms are scattered. And the silence is not a void, but a presence all its own. The sea spaces are not entirely empty. Within them drift lonely hydrogen atoms, thin wisps of gas, wandering photons from ancient stars. But compared to the busy brightness of galaxies, they are deeply still. In some places, you could travel 1,000,000 light years and never meet a star, just darkness and the faint whisper of gravity. And yet these places matter. In their silence, they shape everything. To understand how, we must first see the universe as it truly is, not just a collection of stars, but a great invisible web. This cosmic web is woven from dark matter, a kind of matter that does not glow, does not burn, does not reflect or absorb light. It cannot be seen directly, but its gravity can be felt. It bends space. It guides galaxies. It creates the skeleton on which the universe is built. Galaxies are not scattered randomly. They follow the lines of this dark matter web, clustering along its threads, forming nodes where the filaments meet. In between these threads lie the voids, the great cosmic gaps where almost nothing gathers. These are the spaces between galaxies, the silence between songs. And like the rests in music, they are essential. Without the voids, the structure of the universe would be different. The quiet allows the loud to be heard. The emptiness gives shape to what is full. The intergalactic space, in all its stillness, provides contrast. It lets galaxies form in patterns, in clusters, in shapes that spiral and bloom. Sometimes silence is not absence, it is balance. Scientists study these voids with care. By observing how galaxies are arranged, where they clump, where they do not, we can map the invisible architecture of the cosmos. We learn where dark matter stretches and where it thins. We see echoes of the early universe, fossilized in the shapes of nothingness. And yet these voids are not truly silent. Light passes through them, stretched and redshifted by time. Some believe dark energy flows within them, gently pushing space apart. Others suspect they hold ancient secrets of particles from the dawn of time, drifting undisturbed through their calm. One of the great mysteries is whether something unknown moves in this quiet. The darkness between galaxies is where our knowledge grows thin. It is a place for possibilities, for forms of matter we cannot see, for forces we do not yet understand. In this stillness, new questions are born. Imagine floating there, far from any star. The nearest light is millions of light years away. There is no heat, no sound, only the soft glow of distant galaxies, like lanterns seen from the bottom of a deep sea. You are not alone, though you feel alone. Gravity still touches you, time still flows, and perhaps if you listen carefully enough, you might feel the pulse of the universe not through noise but through rhythm. The rhythm of galaxies moving, slowly drawn by unseen hands. The rhythm of expansion, of space stretching like a breath held too long. The rhythm of something older than light, older than time, passing gently through the dark. Even here in the deepest silence there is motion, there is change. Photons from the early universe pass through these voids on their way to us. Their path is shaped not just by what they see, the galaxies and stars, but by what they do not. The gravity of emptiness bends their course just as surely as mass does. It is a strange truth. The absence of matter can guide the flow of light. This is known as the integrated Sachs-Wolf effect, a subtle shift in the energy of light caused by the stretching of space itself. It tells us that the voids are not just holes. They are active parts of the universe's growth, participating in the great unfolding. And so we begin to see the silence differently, not as an empty page, but as part of the story, not as a pause, but as a note in a deeper music. Let us float here for a while, in this gentle quiet. Let us imagine what it means to live in a universe where silence is not stillness, where the spaces between things are as meaningful as the things themselves. And as we rest in that thought, let us prepare to drift deeper, into the mysteries of dark matter and dark energy, into the invisible threads that guide galaxies through the black. Let us follow the paths of those lonely photons, moving ever forward through the calm, and listen for what the silence still has to say. Let us now drift deeper into this stillness, into the hidden architecture that shapes the silence between galaxies. Though these vast spaces appear empty to our eyes, they are anything but void of meaning. Beneath their calm, invisible hands are at work, guiding, stretching, holding the form of everything we know. We speak here of dark matter and dark energy, the two great mysteries that dwell in the quiet, unseen yet always present. Dark matter does not glow, it does not burn, and it does not collide like the matter we are made of. It moves through the universe without shining, without slowing, without being touched by the forces we know. And yet it is everywhere. It outweighs ordinary matter 5-1. It surrounds galaxies in halos, unseen clouds of gravity, keeping stars from flying apart. It weaves the filaments of the cosmic web, anchoring galaxies along lines we cannot see. Without dark matter, galaxies would not hold their shape. They would unravel into the void. Without it, the universe would be unrecognizable. In the silence between galaxies, dark matter still speaks not with light but with motion. The way galaxies drift, the way clusters pull toward one another, the way space curves and bends, all of this is guided by the gravity of dark matter. Scientists do not yet know what it is made of. It might be particles so faint and strange that they slip through everything, leaving only the faintest imprint of their presence. Or perhaps it is something even more mysterious, a shadow of matter from a mirror world, folded just beyond our reach. We build detectors deep underground, shielded from noise and light, hoping to catch one of these particles. We send satellites into space to study how galaxies cluster. We listen for signs in the echoes of the cosmic background, and still it remains elusive, always there, always just beyond the edge of knowing. And then there is dark energy, the even greater mystery. While dark matter pulls, dark energy pushes. It is the force that makes the universe expand faster over time, stretching space itself like taffy. No one expected this. Scientists thought the universe's expansion might slow, might drift gently toward stillness, but instead it speeds up. Galaxies rush away from each other faster than before. The fabric of space grows thinner, the distances wider. And dark energy, invisible and quiet, is the reason why. It seems to live in the silence, in the space between things. Unlike matter, it does not gather or clump. It does not form stars or planets. It spreads out evenly, like a mist that fills all of space, pushing outward, always outward. And the more space grows, the more of it there seems to be. It is as if the universe is being lifted open by a gentle breath, and that breath grows stronger with time. We do not understand dark energy. We know only that it is real and that it may shape the future of everything. If it continues, the galaxies will drift so far apart that their light will no longer reach us. One day the night sky may grow quiet, the stars too distant to be seen, the silence between them stretched beyond hearing. The universe will not end in fire or collapse, but in a soft fading, a slow retreat into loneliness. And yet, even in that future, the quiet between galaxies will still be full of motion. Neutrinos will pass through space. Photons will drift endlessly. Gravity will still ripple, ever so faintly. The silence will not be nothingness. It will be a memory, a place where the stories of stars once echoed. Some believe the silence is the key to everything, that within the space between galaxies lie the answers we have yet to ask. What is the shape of time? Is the universe finite or infinite? Do other realities fold within our own, separated not by distance but by silence? These questions are not answered by telescopes alone, but by patience, by listening not only to what shines, but to what does not. This is the beauty of the quiet. It holds all possibilities. It does not choose. It does not hurry. It simply is. In the intergalactic voids, the light of galaxies arrives softened and stretched, tired from the long journey. Some photons have been traveling for billions of years, carrying with them the story of stars long extinguished. They pass through these vast regions, through currents of dark energy, through halos of dark matter on their way to us. And when they arrive, we catch them gently, in mirrors, in sensors, in instruments that measure the smallest glimmer. These glimmers are not just data, they are memories, and from them we build our maps of the cosmos. From them we learn where the light came from and where the silence still stretches. When you gaze at the night sky, you are not just looking at stars. You are looking through an ocean of quiet. Every twinkle is a distant shore. Every shadow is a story waiting to be understood. And between those lights, between those galaxies, is the soft, patient breath of the universe itself. So let us listen again to that breath. Let us honor the darkness not as emptiness, but as depth. Let us respect the silence not as absence, but as space for wonder. In the next stillness, let us journey further toward the edge of the cosmic web, where the last whispers of galaxies fade into the pure black. Let us follow a single beam of light as it sails through the intergalactic sea, untouched, unwavering, until it finds a place to rest. Now let us follow that final beam of light, one photon, born in the heart of a distant galaxy, perhaps from the dying breath of a star. It begins its journey in a place alive with brightness, surrounded by other stars, drifting dust and magnetic winds. But as it escapes the galaxy's edge, it enters the deep. The space between galaxies is not marked by walls or borders, but the transition is real. The density drops, the noise fades. The photon begins to sail through the intergalactic sea, a realm so wide, so calm, that it seems untouched by time. There is no path, no highway of light. The photon is not guided, yet it moves steadily, pulled not by will but by nature. In these vast stretches, it encounters little the occasional wisp of gas, the slow pull of dark matter's invisible mass. It continues forward, unwavering, as space itself stretches beneath it. Its wavelength elongates, its color shifts. What began as a burst of energy becomes a soft murmur, redder, cooler, gentler with every passing million years. This journey may last 1 billion years or more. The photon does not know, it does not tire or slow, it simply continues. Through voids where galaxies are but distant glimmers, through darkness where the fabric of space is thin, it presses on. And in that persistence, there is a lesson that even the smallest thing can carry light across the darkest places. That motion itself is a form of memory. Eventually, the photon may reach a distant world, a distant eye, a quiet detector floating above Earth's blue sky. It may strike a mirror or a sensor cooled to silence. In that instant, the story ends. The photon is absorbed, its energy recorded, its message read. It has arrived. And though it has no voice, what it tells us is vast. It speaks of its source, of its path, of the silence it passed through. It carries the shape of a galaxy no longer seen, the fingerprint of space's expansion, the memory of a universe in motion. This is how we see the silence between galaxies, not by touching it, but by listening to what comes through it. Every photon, every wave of light is shaped by the space it has traveled, the gravity it felt, the energy it left behind. In this way, even the emptiness becomes part of the story. And perhaps this is the deepest truth the universe gives us, that what we do not see matters as much as what we do. That silence can shape sound. That space can shape time. That the places between things, between galaxies, between stars, between thoughts, are not blank, but full of quiet meaning. Even now, between every galaxy, there are billions of photons crossing the void. Some were born before Earth existed. Some will never find a home. But they travel anyway, casting no shadow, seeking no end. And in their journey, the universe reflects its own stillness back at us. When you close your eyes beneath the stars, you are not simply looking into distance. You are looking into the spaces where distance becomes silence, where light becomes memory, where gravity whispers without shape, and in those spaces your own body glows faintly with stardust, shaped by the same quiet that moves galaxies. The atoms in your blood once passed through such silence. The calcium in your bones was made in a star, which lived in a galaxy, which drifted in the web of space. The story of your being is a thread stitched between countless galaxies, through the gaps and pauses of the cosmos. You are not separate from the silence. You are the silence given form. So let us rest now in this awareness that the darkness between galaxies is not something to fear, but to feel. It is a place of possibility, a cradle for the unseen, a home for the great questions. And in that stillness we learn to listen better. We learn to pause. We learn to wonder not only about what is, but about what holds it all. We learn that in the silence between galaxies, the universe is most itself, unhurried, unseen, and yet utterly alive. This is the silence between galaxies. Not nothing, not empty, just waiting. There is a particle so small, so fleeting, that it dances in and out of existence like a flicker on the edge of sight. It does not last long, it does not stay still. And yet it remembers something ancient, a moment, a touch, a trace of light from long ago. This is the photon's quiet twin, the particle with no name spoken aloud in the dark. It is the spark that comes and goes, carrying with it the memory of light. From the first breath of the universe, light has always been moving. But light is not just brightness. It is not just what helps us see. It is energy in motion, vibration in the fabric of space. Photons, the particles of light, carry no rest mass. They do not slow down. They move at the speed of light because they are light. And with every moment they remember the place they came from, a star, a fire, a fusion reaction, or something older still. But there are particles that only appear for a moment, born from the meeting of energy and mass, disappearing in the same breath. These particles, like virtual photons, key neutrinos, like other quantum echoes, carry a kind of memory we cannot hold in our hands. They do not last long enough to be seen, but their presence is felt, a force here, a curve there, a ripple in the balance of nature. When two charged particles interact, say, two electrons moving near each other, something strange happens. They do not touch. Instead, they exchange a photon. Not a photon like the ones that bring us sunlight, but a virtual photon, a messenger particle, invisible and brief. It appears for just the tiniest fraction of time, just long enough to deliver a push or a pull. And then it is gone, but even in that blink it carries information, direction, strength, memory. This is how the electromagnetic force works, not through constant contact, but through quiet exchange, through the borrowing and lending of light's smallest pieces. And these exchanges happen everywhere, all the time, within atoms, across distances, even in the emptiness of space. Each time a whisper of energy is passed and something moves. It is a beautiful system, a ballet of presence and absence, of particles that are not quite real and yet entirely necessary. They hold no shape, no permanence, but without them, atoms would fly apart. Without them, chemistry would vanish. Without them, there would be no bonds, no light, no life. In this strange quantum world, memory is not held like it is in your mind. It is written in the probabilities, in the patterns that emerge from chance. When a photon bounces off a mirror, it remembers the angle it arrived with. When it moves through glass, it slows down just slightly, adjusting to the resistance. When it is absorbed by a leaf, it becomes something else: food, fuel, warmth. And even in that change, it leaves a mark. Every time light touches something, it tells a story, and though the photon itself may vanish, the story remains: a warmed surface, a shifted electron, a signal carried across space. And sometimes that story travels far, across the vacuum between stars, across billions of years. Some of the photons that touch your skin today may have been traveling since the dawn of galaxies. They have not forgotten where they began. They carry the color of their birth, stretched and softened by time, but still true. This is why we can look back into the past with telescopes, not by guessing but by catching, by holding these old particles of light in a lens, a mirror, a sensor. They arrive tired, slowed not in speed, but in energy, redshifted like a song played a little lower than it was sung. But the melody remains. It tells us of stars that burned long ago, of explosions, of movements, of silence. And deeper still, inside each atom, more memory is held. Electrons, spinning quietly in their orbits, carry energy states that remember every interaction. When a photon is absorbed, the electron jumps. When it releases that energy, the photon is born again. A cycle of exchange, a dance of giving and taking, a memory passed on. In this way, light itself becomes a thread through time. Not just a wave, not just a particle, but a storyteller. And though its stories are quiet, written in patterns, in pulses, in polarization, we are learning how to read them, with instruments, with patience, with wonder. Imagine now a single photon created in the core of the sun. It begins its life not in light, but in heat, in the crushing pressure of nuclear fusion, where hydrogen becomes helium. That photon takes thousands of years to escape the dense layers of the sun. It bounces endlessly inside, scattering from atom to atom, pushed and pulled in every direction. But eventually it reaches the surface. And then in a blink, it is gone, racing out at the speed of light, traveling through space, past planets, clouds, and sky. Some of those photons reach Earth, some enter your eye, some warm your skin, and though you do not feel their journey, they remember it, not in thoughts but in presence. They are here because of all they passed through, every moment of resistance, every curve of gravity, every echo of time. Let us pause with that thought. That light born in fire could cross space, touch your hand, and disappear, leaving only warmth. That the universe shares its memory not in words but in energy. That a single particle can carry the story of a star. And as we drift into this light, let us prepare to go deeper, into the quantum mysteries that shape the movement of these particles, into the strange spaces where light and matter blur, and where the tiniest pieces of reality hold memories more ancient than we can imagine. Let us follow the thread further, not just into what light is, but into what it remembers. Let us now journey deeper into that memory, the kind not written in books or carved into stone, but held within the invisible rules of the universe. In the world of quantum mechanics, light behaves in ways that defy our everyday understanding. It is both a wave and a particle, both presence and possibility. And this duality, this dance between forms, holds within it the oldest stories of energy, of motion, of time itself. When we speak of a photon remembering, we do not mean memory like ours. A photon does not think, it does not recall in words or images, but it moves in a way that respects where it came from, what it touched, and how it was shaped. It carries that imprint forward, embedded in its direction, its frequency, its polarization. It remembers by being, and in the quantum world, to be is to hold a trace of every interaction. Light at its most delicate level is made of quanta, discrete packets of energy. These quanta can interfere with each other, even with themselves. In the famous double-slit experiment, a single photon can pass through two slits at once, as if testing both paths until one is chosen. But until we look, until we observe, the photon exists as a possibility, a spread-out wave of maybes. And once we observe it, it makes a choice, or appears to. It lands in a single spot, on a screen, in a detector. And in that landing, the wave becomes a point. The memory becomes real. What decides where the photon goes? What carries it from maybe to here? These are the questions at the heart of quantum theory. And though we may not have all the answers, we know this: the photon's journey is not random. It follows laws, subtle and complex, shaped by interference, by superposition, by entanglement. It listens to the world around it, to the openings available, to the boundaries imposed, and moves accordingly. This listening is not conscious. It is embedded in the mathematics of the universe, but the effect is clear. Light remembers paths, it remembers the shape of its environment. When light moves through a crystal, it splits into colors depending on the angles, the thickness, the structure of the lattice. That split is predictable because the light remembers what it passes through. When it reflects off a surface, it obeys the angle of incidence, the rules of geometry. But beneath those rules lies something quieter, the imprint of all previous interactions, guiding its path. Entanglement adds another layer to this story. When two particles, such as photons, become entangled, they are linked across space. Measuring one affects the other instantly, no matter the distance. This is not communication in the classical sense. It is not a signal. It is a memory, shared and indivisible, created in a moment and preserved without wires or waves. It is as if the universe itself remembers the connection, even after the particles have parted. Experiments have shown this again and again. A photon entangled with another carries its twin's information, not as cargo, but as identity. When we observe one, the other responds. This connection does not weaken with space. It is not slowed by time. It is a thread through reality, a quiet reminder that the universe holds memories not just in things, but between them. Even when a photon is absorbed, say, by a leaf or a sensor, its energy is not lost. It is transformed. The atom that absorbs it jumps to a higher state. It stores the energy briefly, like a held breath. And later it may release that energy as another photon, or as heat, or as a chemical bond. The original photon is gone, but its essence remains. It is memory in motion. And motion in physics is never without cause. Think of your own body. Every signal your eyes send to your brain begins with a photon. It touches the molecules in your retina, causing them to change shape. That change starts a cascade, a signal that travels through neurons across synapses into awareness. Your vision begins with light, but also with memory. The memory of the photon's origin, the color it carried, the direction it came from. Every sight you've ever seen began with a particle that traveled from another place, sometimes another world, sometimes another star. And these photons, before they reached you, lived a long life. Perhaps they bounced from one atom to another inside a star for tens of thousands of years. Perhaps they journeyed across space for millions more. Perhaps they slipped through clouds, past moons, through your window and into your eye, all without slowing, without forgetting. They arrived unchanged in speed, but shaped by time. We are learning to use these properties in new ways. In quantum computing, photons are used to carry qubits, units of quantum information. Unlike classical bits, which can be either 0 or 1, qubits can be both in superposition, and they can be entangled, sharing state across vast distances. This allows for powerful new forms of processing, where information is not stored in a place but in relationships. Memory becomes something woven, not held. Quantum communication uses entangled photons to send messages that cannot be intercepted without detection. Any attempt to measure or copy the signal changes it, revealing the intrusion. In this way, photons are not just carriers of light, but guardians of secrecy. They hold the past so delicately that even a touch reveals a change. All of this reminds us that particles are not simple. They are not just dots in space. They are expressions of rules, of order, of probability. They are histories in motion. So let us pause again and feel the presence of that light. Not just the light that shines, but the light that once was, the particles that have touched the earth, the ocean, your skin. The ones that came from ancient stars, now gone. The ones that warmed the first seeds. The ones that showed the way. Their memory is not stored in books or machines. It is stored in movement, in change, in quiet transformations. It is stored in the way light bends around gravity, in the way it stretches through time, in the way it disappears, not into nothing, but into something else. As we move forward, let us follow that transformation. Let us see how light becomes matter, how photons give rise to mass, to form, to life. Let us listen more deeply to the memory they carry, not just of where they've been, but of what they become. Let us now follow light into its final transformation, the moment where it gives itself away, where it becomes something else entirely. A photon, pure energy with no mass, can become matter under the right conditions. This is not metaphor. This is not magic. It is the quiet law of the universe that energy and mass are not opposites but reflections. The light you see, the light that touches your face, can, if caught in the right moment, become a particle with weight, with presence, with permanence. This happens in the early universe, where temperatures soared and space was thick with possibility. There, in the first seconds, energy gave birth to matter. Photons collided with each other in blinding flashes, their energy dense enough to create particles, electrons, positrons, quarks. These were not born of dust or fire, but of light. It was light becoming mass, motion becoming memory, the beginning of form. And even now, under special conditions, we see this again. In powerful accelerators, where particles are pushed near the speed of light, high-energy photons can collide and create pairs of particles, a matter particle and its twin of antimatter. They appear for a moment, dance, and often vanish again, annihilating back into light. But in that brief appearance, something extraordinary happens. Energy takes shape. A ripple becomes a knot. A passing wave becomes a point in space. Every atom in your body was once born of this process. Not just born of stars, but born of light itself. The electrons in your cells carry the whisper of photons long transformed. The particles that form you were once only energy, once only motion, once only possibility. And now, here you are, walking, breathing, dreaming, a shape made from ancient light. This transformation is not just a process of physics. It is a story of becoming, a reminder that nothing in the universe is ever lost, only changed. Light becomes matter. Matter becomes energy. Energy becomes warmth, thought, life. And even when a photon ends, when it is absorbed, transformed, it is not gone. Its energy remains, passed on, carried forward like a memory retold in a new language. In the center of stars, light is constantly born and reborn. Fusion reactions release photons, which travel outward through the dense plasma, colliding, scattering, losing their way. Each photon might take thousands of years to reach the surface, changing direction billions of times. By the time it emerges into space, it remembers nothing of its path, only its birth. It carries that original energy, softened by its journey, stretched by the star's gravity, ready to wander again. This is not unlike us. We too are shaped by countless collisions. We are formed by interactions, by pressure, by time. And when we reach the surface of our lives, when we step into the world, into the space beyond our origins, we carry with us the energy of our beginning. It may be softened, it may be redshifted by experience, but it is still there. Some photons never become matter. They move forever through the cosmos untouched. They travel billions of years without meeting anything at all, but even they leave traces. They shift when they pass through gravity. They slow when they pass through water. They change direction when they reflect off glass. In each moment they adapt, they respond, they remember. And when they are finally caught in the eye of a telescope, in a sensor buried deep underground, they give their story. Not in sound but in signal, not in words but in numbers. And from those numbers we build pictures. We see galaxies, stars, nebulae. We read the age of the universe. We trace its expansion. We understand in part who we are. But even beyond that, beyond the science and the data, there is something more. There is awe, there is quiet realization that everything you have ever known, every book, every tree, every song is built from particles that once were light, that carry within them the energy of something older than Earth, that hold in their motion the shape of time. This is the photon's gift. It asks for nothing. It moves without resistance. It gives itself freely to vision, to warmth, to life, and in that giving it becomes something else. It becomes memory. It becomes presence, it becomes us. So as we close this story, let us not think of light as only what helps us see. Let us think of it as what we are, what we were, what we will be. Let us remember that every moment of warmth, every flicker of sight, every gentle glow, is part of a cycle that began at the dawn of time, a cycle in which particles are born, live, and transform, a cycle in which even something as fast and fleeting as a photon can leave a lasting trace. The photon does not stop to reflect, it does not look back, but in its path we see reflection, in its light we find history, in its presence we remember. This is the particle's memory of light. Not written, not spoken, but carried forward forever. In the beginning there was no breath, there was no rhythm, only a great unfolding, a silent bloom of time and space. But as the universe stretched itself outward, as galaxies formed and stars ignited, something soft began to emerge. A rhythm, a pulse, a quiet exhalation of warmth and motion. It was as though the cosmos had learned to breathe. This breath is not made of air. It is not lungs drawing in or out. It is the slow expansion of space, the curling of gravity, the flow of energy through matter. It is the rise and fall of radiation, the soft inhaling of dust into stars, the long exhaling of light into darkness. It is time moving gently forward. It is the heartbeat of the universe. We do not always feel this breath. Our lives are short. Our rhythms are quick. A breath for us takes only seconds. But the breath of the cosmos stretches across billions of years. Each expansion, each contraction, each wave of matter across space, these are its inhale and exhale. Each moment of creation is a pulse. Each collapse a rest. In the early universe, everything was dense and hot, pressed together in a kind of cosmic silence. But even then, tiny fluctuations were taking shape. Pockets of slightly higher density gathered mass, pressure pushed outward, gravity pulled inward. This balance between compression and expansion became the first rhythm, a kind of breathing that would shape the universe's structure. These fluctuations gave rise to sound waves, pressure waves that rippled through the plasma of the young cosmos. Though space was too dense then for light to travel freely, these waves moved like the breath of a sleeping giant. Their echoes are still visible today in the cosmic microwave background, faint ripples that tell us how the universe once sighed. Later, as stars were born, a new rhythm emerged. Within the hearts of these stars, fusion began, hydrogen becoming helium, light pouring out in steady streams. The stars pulsed in their own way, some expanding and contracting, some shining with constant fire. When they died, they exhaled matter into space, carbon, oxygen, iron, the elements that would one day become planets and life. The breath of a star can last billions of years. It draws in gas, fuses it, and releases it as light and wind. When it collapses, it sends shockwaves into the cosmos, creating nebulae and forging new stars. And so the breath continues, moving from one form to another, from gas to fire to dust to seed. Planets form in the quiet between these pulses. In the disks of gas left behind by dying stars, new worlds begin to gather. Gravity pulls dust together. Small stones become larger ones. Heat and pressure shape their cores. And eventually some of these planets settle into orbits, circling stars in a slow, steady rhythm. Day and night, season after season, breath after breath. Earth too carries this rhythm. Its tides rise and fall with the moon. Its atmosphere flows with winds and storms, its forests breathe carbon and oxygen, its oceans exchange warmth with sky. And life, born from this rhythm, breathes too. Every lung, every leaf, every wave of blood is part of this larger motion, a reflection of the cosmic breath that began at the dawn of time. Even time itself seems to breathe, not in speed or slowness, but in the way it stretches and curls. In the presence of great mass, like a black hole, time slows. In the deep voids of space, it runs faster. It is as if the universe inhales around mass and exhales where it is empty, folding itself gently around what it holds. This breathing is subtle. It does not shake the sky, but it is everywhere. It is in the expansion of galaxies slowly drifting apart. It is in the background hum of cosmic radiation. It is in the gravitational waves that ripple out when black holes collide, the deepest sighs the universe can make. And so, though we cannot always hear it, the cosmos is not silent. It is alive with motion, with breath, with gentle tides of being. Let us pause here and feel this breath, not with ears but with awareness. The breath that moves not through lungs but through stars and space and time. The breath that touches every atom, every planet, every flicker of light. Let us prepare to follow this rhythm more deeply, into the ways galaxies flow, into the pulses of neutron stars, into the gravitational waves that pass unseen through our world. Let us listen for the inhale and the exhale of the cosmos, for in that rhythm we find not only motion, but meaning. Let us now step deeper into the rhythm of the cosmos, into the great breath that shapes galaxies and stars. The universe expands, a quiet, ceaseless stretching of space, and this expansion is not just movement outward, but a slow, continuous exhale. Galaxies drift apart not because they are moving through space, but because space itself is growing between them. It is not a pushing, not a force as we usually imagine it, but a swelling. A gentle widening of the very stage upon which everything dances. This expansion has not always been at the same pace. In the early moments after the Big Bang, the universe grew faster than light, in a burst we call inflation. In that brief instant, the seeds of all structure were planted, the wrinkles and waves that would one day become stars and planets. Then the expansion slowed, allowing gravity to take its turn to draw things together, to shape and settle. Galaxies formed, clusters emerged. But now the expansion has begun to speed up again, driven by dark energy, that strange, invisible breath that seems to fill space itself. This is the breath of the cosmos, a balance between stretch and stillness, between gathering and letting go. It is the same breath that lives in you. When you inhale, your lungs expand. When you exhale, you release what is no longer needed. The cosmos breathes in its own way, taking time not in seconds, but in epochs, and with every breath it changes just slightly, grows just slightly, evolves. Inside galaxies, this rhythm continues. Stars are not fixed. Some pulse with steady beats, expanding and contracting in slow cycles. These are the variable stars Cepheids and RR Lyrae, whose rhythmic brightness allows us to measure distance across the universe. Their breath is so regular, so reliable that it becomes a tool, a heartbeat we can trust. When we see their flicker, we are reminded that even faraway stars have rhythm. Even the light we catch from distant galaxies has timing. Then there are neutron stars, the collapsed cores of massive stars spinning rapidly, sending out beams of radiation like lighthouse signals. Some of these are pulsars, and their rotation is more precise than the ticking of a clock. One rotation every few milliseconds, like a breath held tightly, repeated again and again without fail. They are the metronomes of the universe, keeping time not with gears or springs, but with gravity and spin. Even black holes, which seem to devour rather than breathe, are part of this rhythm. When two black holes spiral together and merge, they release gravitational waves, ripples in the fabric of space itself. These waves pass through galaxies, through stars, through Earth, stretching and squeezing space as they go. They are the deepest form of breath, a wave not of air but of spacetime, not of sound but of being. We have only recently learned how to listen to them. In observatories like LIGO and Virgo, long arms of laser light stretch across the land, watching for the smallest tremble. And when a wave arrives from an event that may have happened billions of years ago, we hear it not as a roar but as a chirp. A rising tone, brief and soft, like the sigh of a universe remembering its own heartbeat. But this breath is not only in stars and space. It is also in the patterns of life. On Earth, ecosystems follow rhythms of day and night, of seasons, of migration. Trees breathe in carbon and release oxygen. Oceans inhale heat and exhale storms. Animals live by cycles, circadian rhythms, lunar tides, solar paths. Life itself has grown into the shape of the cosmos's breath. Even our thoughts have rhythms. The brain pulses with waves, alpha, beta, delta, that shape how we sleep, how we feel, how we remember. These waves are not separate from the universe's rhythm. They are part of it. Born from atoms forged in stars, carried forward in bodies shaped by Earth's tides, our minds are echoes of ancient breaths. And yet we often forget this. In the rush of time, in the noise of days, we lose touch with the slower rhythm beneath it all. But it is always there. When you close your eyes, when you feel your own breath, when you listen to silence, you can sense it. The breath of the cosmos, slow and vast, moving through ever. Living. This breath is not perfect. It wavers. Galaxies collide, stars explode, planets shatter. But these are not the end of breath, they are part of it. Even death in the cosmos gives way to new creation. A supernova scatters heavy elements into space, seeding new worlds. A collapsing star becomes a black hole, which warps time, which shapes space, which continues the breath. And somewhere in the middle of this rhythm is us, listening, learning, wondering. We are not observers, separate and still. We are participants, breathing too. Our breath is short, yes. Our lives a moment. But in that moment, we are part of a breath that spans time and space and silence. Let us hold on to this awareness. Let us remember that the universe is not static. It is not frozen. It is breathing, slowly, deeply, eternally, and so are we. Let us move now toward the final part of this story, to how breath gives rise to balance, to beauty, to becoming. Let us feel how even in stillness there is pulse. Even in the quiet there is motion. Let us exhale and continue. Let us now follow the breath to its final unfolding, to the soft edge where motion becomes stillness again, and the rhythm of the cosmos becomes something we can almost touch. For in this final exhale, we see how the universe does not only expand, not only move, but settles into patterns of balance. These patterns, the spin of a planet, the orbits of moons, the alignment of galaxies in clusters, are the breath crystallized. It is easy to think of the universe as chaos, stars exploding, galaxies colliding, space rushing outward. But beneath that motion lies a harmony so precise it almost disappears in its perfection. The breath of the cosmos is not a wild storm. It is a slow dance, unfolding over billions of years. It is equilibrium found in expansion, beauty born from balance, change rooted in consistency. This is how spiral galaxies form, not from violence, but from a slow swirling of matter around a common center. Their arms stretch outward not in haste, but in the rhythm of rotation like petals unfurling on an invisible wind. The Milky Way itself turns once every 225 million years, its stars gently circling the galactic core. This, too, is breath, one so long we cannot count it, but one that holds our sun within its steady inhale. Even galaxies that collide do not always destroy one another. Often they merge, slowly blending their stars and dust, reshaping into new forms. Ellipticals, irregulars, warped spirals. These are not ruins. They are the result of breathing together, of rhythms merging, of forces finding new shapes. Between galaxies in the vast stretches of intergalactic space, there is breath as well in the slow flow of gas, in the drift of dark matter, in the quiet tide of expansion. It is here that cosmic filaments stretch like rivers through a black ocean, threading matter from one node of the universe to another. It is here that gravitational wells rise and fall, like the inhale and exhale of tides on a cosmic shore. And all the while within these great structures light flows. It travels not as noise, but as melody, curved by gravity, slowed by dust, stretched by time. Photons pass through clusters, through galaxies, through us. Their motion is guided by the breath of space itself. They do not rush, they do not rest, they move in harmony with everything around them. This is the deeper lesson of breath, that motion can be peace, that expansion need not be disorder, that the universe is not simply rushing toward emptiness, but finding shape through every breath it takes. Even as it grows colder, even as the stars slowly burn their last fuel, the cosmos does not end, it transforms. It exhales not to disappear, but to become something else. Galaxies will fade, black holes will remain, the breath will grow longer, slower, but the rhythm will continue, always. And here on Earth, in the curve of a tree's branch, in the rhythm of a heartbeat, in the orbit of a moon, we feel echoes of this breath. Our own cycles, waking and sleeping, growing and resting, living and letting go, mirror the cosmic pattern. We rise and fall, we gather and release, we breathe too. Even the stories we tell, the way we remember, follows this rhythm. We begin, we expand, we return. Our thoughts move in waves, our feelings crest and quiet. Our lives are breaths in the greater lung of time. So the next time you sit in silence, listen not just to the sound of your own breath, but to what it belongs to. Imagine space stretching quietly beyond your skin. Imagine galaxies turning slowly in the black. Imagine light moving, memory unfolding, matter flowing through invisible threads. All of it breathings. all of it moving not to escape, but to become. Let that rhythm comfort you. Let it remind you that nothing is ever truly still, that even in solitude you are part of motion, that even in silence you are part of sound. Because the cosmos does not rush, it does not worry, it does not hold tight, it breathes, and in doing so it allows everything, stars, planets, thoughts, dreams, to unfold gently. This is how the cosmos learned to breathe. Not once, but always. Not with lungs, but with time. There is a force that does not shout. It does not flash across the sky like lightning. It does not crackle or burn. It does not rush or rage. And yet it holds stars in their places, shapes the paths of moons, and keeps your feet gently pressed to the ground. This is gravity, the quiet weaver of the cosmos, the soft hand beneath all falling things. Gravity is not a push or a pull in the way we often imagine. It is not a string tugging you toward the Earth or a magnet drawing the planets toward the sun. Instead, it is the bending of space itself. When something has mass, it curves the fabric of space around it. Like a stone resting on a stretched sheet, it causes a dip, a fold, a well. And other things, moving nearby, feel that curve and begin to follow it, not because they are being pulled, but because space itself has changed. This is why planets orbit stars, not because they are leashed, but because they are falling forever around a curved space they cannot escape. This is why moons circle planets, why comets sweep in long arcs, why galaxies spin with grace. All are moving through space that is shaped by gravity. All are following the gentle folds of the universe. When Einstein showed us this truth, he changed how we understood everything. He told us that mass and space are not separate, that energy and time are not strangers, that the universe is a fabric and gravity is the soft stitching that holds it together. And suddenly everything became more beautiful, not less mysterious, but more tender. Because now we saw that even the simplest thing, like a falling apple, is not small. It is a conversation with the cosmos. And yet, for something so foundational, gravity remains elusive. We can measure it, we can feel it, but we do not fully understand it. It is the weakest of the forces, weaker than electromagnetism, weaker than the nuclear forces that bind atoms. And yet, it is the one that rules the large, the one that governs stars, galaxies, and the fate of the universe itself. Perhaps it is because gravity is so steady, so quiet, that we forget how strange it really is. Why does it only attract and never repel? Why does it act instantly across distance? Why does it curve not only space but time? We do not yet know the full answers, but we are listening. We see gravity's touch everywhere, in the way tides rise and fall, pulled gently by the moon, in the way your body leans slightly toward the Earth's center even when you stand still, in the way light itself bends when it passes near a massive object like a star or a black hole. Even light, which has no mass, feels gravity. It follows the curve of space, changing direction like a stream flowing through a valley. This is how we first saw what Einstein predicted by watching starlight during a solar eclipse. The stars near the sun appeared slightly shifted, their light bent by the sun's gravity. Not much, just a tiny shift, but enough to show that space is not flat, enough to prove that even the path of light is shaped by presence. And gravity's secrets do not end there. Black holes, those mysterious regions where gravity becomes overwhelming, are among the strangest objects in the universe. They are not holes in the usual sense. They are places where space folds in on itself so tightly that nothing can escape, not even light. A black hole is what happens when mass gathers too closely, presses too deeply, bends time and space until they seal shut. But black holes are not only ends, they are storytellers. Around them, matter spirals in brilliant disks, heated to glowing as it falls inward. Some black holes spin, twisting space around them like a whirlpool. Some release jets of energy that shoot across galaxies, and all of them carry with them a hidden past, the memory of the stars they once were. We cannot see inside a black hole. Its center, the singularity, is beyond knowing, but its edge, called the event horizon, is where space bends so much that the journey inward becomes permanent. Once crossed, no message can return. It is not violence but finality, not destruction but silence. And still we watch. We measure the stars that orbit these invisible centers. We catch glimpses of the glow around their edges. We listen for the gravitational waves that ripple outward when black holes merge, soft tremors in the fabric of space itself, like the deep breath of mountains shifting in the dark. Even here on Earth, gravity whispers. It shapes the flow of rivers, the growth of trees, the balance of clouds. It guides the wings of birds and the weight of raindrops. It holds us close to the ground, not as a prison, but as a quiet anchor. It reminds us where we belong, and when we jump, it brings us home. Let us pause and feel it, the downward softness of gravity, the silent way it reaches into your bones. It does not force, it does not rush, it only reminds, a presence without sound, a direction without pressure, a kindness beneath all motion. Now let us drift deeper into gravity's secrets, into the curvature of time itself, into the orbiting hearts of galaxies, into the paradoxes of falling forever. Let us listen for the questions that gravity asks, not with words, but with weight. Let us now journey further into gravity's quiet mysteries, into the places where its pull stretches not only space, but time. For gravity does not simply bend the fabric of where things are, it bends the very rhythm of when things happen. In its presence, clocks run slower, not broken, not malfunctioning, just more patient, more still. This is time dilation, a truth whispered by Einstein's theory of general relativity. The stronger the gravity, the slower time moves. Near the Earth's surface, time ticks ever so slightly slower than it does high in the mountains. On a satellite in orbit, time moves just a bit faster. It is a small shift, imperceptible in daily life but measurable. Our GPS systems rely on it. Without correcting for this soft difference, they would lead us astray. And so, even the directions we follow across cities are shaped by gravity's subtle command over time. But when gravity grows stronger, around neutron stars, around black holes, time slows more dramatically. Near the edge of a black hole, a single minute might stretch into years when viewed from afar. And beyond the event horizon, where no return is possible, time itself may stop entirely. What lies beyond that edge is not just unknown. It is unreachable, not because of distance, but because of time's collapse. This bending of time is not science fiction. It has been tested, measured, confirmed. And yet it feels like magic. That something so familiar, a ticking clock, a human heartbeat, could change simply by being near something massive. That time is not a constant flow, but a stream that can slow, twist, even eddy like a quiet river in the shadows. In galaxies, gravity draws stars into spirals, pulling them inward, shaping their orbits across millions of years. The very structure of galaxies depends on this slow balance, the stars moving too fast to fall inward, yet too bound to escape. This balance, so fragile and exact, is what allows galaxies to exist as graceful systems instead of dissolving into chaos. But there is more mass in galaxies than we can see, much more. The visible stars are only a fraction. The rest is dark matter holding everything together with invisible gravity. We do not yet know what this matter is made of, but we feel its presence. Without it, the outer stars in a galaxy would drift away. They spin too fast to be held by visible matter alone. It is as though a hidden hand cradles the galaxy, keeping it whole. This too is gravity's secret. It does not demand attention. It does not glow. But it is the quiet structure behind every luminous thing. It tells stars where to dance. It guides light through curves we cannot see, and it holds galaxies in its invisible arms for billions of years. Even in the great voids between galaxies, gravity has a role. The absence of matter creates gentler fields where particles drift in wider, slower arcs. These spaces may seem empty, but they are part of the grand tension, the stretch between clustering and scattering, between collapse and escape. Gravity does not only pull things in, it defines the very space that things move through. Without it, there would be no shapes, no flow, no story. We are beginning to see gravity in new ways through new instruments. Gravitational wave detectors like LIGO and Virgo have opened a new kind of hearing. They do not listen to light, they listen to space itself. And when massive objects merge, black holes, neutron stars, the waves they send ripple outward, changing space by the smallest amount. We measure these ripples as changes in length, less than the width of a proton, but full of meaning. When a signal arrives, we know something vast has happened, not now, but millions or billions of years ago. Two stars may have spiraled together, falling inward until their surfaces touched, their cores collided, and their masses fused. The energy released travels through space not as light, but as breath, soft and deep, warping everything in its path. And yet these waves do not crash, they do not roar. They arrive silently, almost politely, touching our detectors with the gentlest nudge. But from that nudge we learn everything, the masses of the stars, their speeds, the shape of their final embrace. This is what makes gravity so quietly powerful. It connects the immense with the invisible. It shapes stars and lifts oceans. It slows time and carries memory. It is the form of belonging, the way things remain near one another across emptiness. In your own life, gravity is always at work. It keeps your feet on the ground, yes, but it also holds the air around you. It draws rain from clouds. It shapes the path of a falling leaf. It guides rivers toward the sea. It pulls the tides in and out. And though we seldom notice, we are constantly in dialogue with it through balance, through movement, through the sense of down. Even love, even longing, sometimes feels like gravity, a drawing near that needs no explanation, a pull we follow without knowing why. Perhaps this is just a metaphor, but perhaps in some quiet way the metaphor holds truth, that just as matter curves space, presence curves experience, that just as gravity holds planets, care holds hearts. So let us sit with this, in the stillness between moments, in the weight that makes us real. Let us feel gravity not as something that drags us down, but as something that gathers us, that holds us, that gives shape to our lives and keeps the stars from drifting too far apart. And now let us continue to gravity's softest edge, where it blurs into the quantum, where it meets time's beginning, where its secrets are not yet understood. Let us walk gently toward the mystery of why things fall and what they fall into. Let us now drift toward the edge of what we know, where gravity becomes a whisper within quantum stillness. Here, in this delicate space between the very large and the very small, gravity's familiar strength begins to dissolve into mystery. We understand its shape on vast scales, how it binds galaxies and curves spacetime, but in the world of atoms and particles, it does not behave the way the others do. It becomes quieter still, almost hidden. This is one of science's great puzzles. Gravity is seamless across distance, but in the quantum world, the realm of electrons and quarks, of uncertainty and spin, it resists being written into the same language. While other forces are carried by particles, photons for electromagnetism, gluons for the strong force, bosons for the weak, gravity has no confirmed messenger. We call it the graviton, this particle we have never seen, but even the name is a hope. A placeholder for a truth we haven't yet caught. And still, gravity moves through the quantum world. It shapes atoms into stars. It holds the Earth close enough to the sun for life to unfold. It acts with infinite patience, never vanishing, never needing to be reset. It is not strong, but it is relentless. Some scientists believe gravity might emerge from something deeper, not a fundamental force, but a result of information and entropy, of tiny units of change woven together. Perhaps it is born from the shape of space itself, the way bits of data arrange into curves. Others wonder if spacetime itself is made of quantum threads, loops, or strings vibrating just beyond perception, and that gravity is their song, their rhythm. These ideas are young, tender. They have not yet grown into full understanding, but they show that gravity may be more than a force. It may be a condition, a shadow of something even more essential. And so we look for its clues in the places where the rules break down, in black holes, where matter becomes so dense that gravity closes around it. In the first moment of the universe, when everything was compressed into a single, unthinkably small point. At the center of black holes and at the beginning of time, gravity and quantum mechanics must meet, but we do not yet know how they greet each other. What happens to information that falls into a black hole? Is it destroyed, or does gravity keep its memory, written into the edges of space, hidden in its horizon? This is the black hole information paradox, a question not just of physics but of meaning. If information can be lost, what else might be? If gravity forgets, does the universe? Some believe that nothing is ever truly erased. That information is preserved somehow in hidden dimensions or subtle changes in space. That even the fall into a black hole is not the end, but a transformation from one kind of knowing to another. In this view, gravity does not erase. It encodes, it softens, it enfolds. And so we build models and equations and detectors. We test the bending of light. We listen to the merging of black holes. We simulate the early universe. We chase gravity into smaller and smaller scales, hoping it will show us its most secret face. But it remains, as ever, softly out of reach. It does not vanish. It does not resist. It simply continues, holding everything always. Perhaps that is why gravity feels so gentle. Not because it is weak, but because it is generous. It gives everything its place, the orbit of moons, the dance of galaxies, the arc of comets, the curl of roots in soil. Even time flows in gravity's rhythm, leaning into its presence like wind into hills. And you too are part of this story. Gravity is not only around you, it is within you, the atoms of your body are shaped by it. Your bones, your muscles, your breath, they all evolved in conversation with Earth's pull. When you lie down to sleep, you feel its softness. When you leap, you feel its return. It holds you not to bind, but to remind that you belong. There is no place in the universe where gravity does not reach. It touches everything, even across the vastest distances. It does not shout, it does not demand, it simply holds, a quiet promise beneath all motion. So let us close this story gently in honor of that quiet. Let us walk barefoot in the idea that falling is not failure but participation, that what comes down is not lost but returned, that even the drifting of planets, the spiraling of galaxies, the collapse of stars, all are acts of belonging. This is gravity, the softest force, the oldest guide, the one that curves space, holds time, and never lets go. There are places in the universe where space does not sit still, where time does not pass quietly, where something deep and unseen begins to stir, not with movement but with rhythm. These are the places where space-time itself begins to sing, not in sound, not in voice, but in waves, long, slow ripples that move through everything, carrying with them the story of things too massive to hold, too distant to see, too silent to hear in any other way. This music is made of gravity, not the kind we feel in our feet, but the kind that moves through stars and galaxies like a forgotten tide. These waves, gravitational waves, were once only a theory, a quiet prediction hidden within Einstein's field equations. He imagined them not as sudden or sharp, but as echoes, subtle and long, born from the movement of great masses in deep space. But for 100 years we could not find them. They passed through us unnoticed. And then one day we heard them. In 2015, the LIGO observatory caught something strange, a pattern in the light, a shift in length so small it defied imagination. It was the stretch and squeeze of space itself, caused by two black holes spiraling into each other more than 1 billion light-years away. The signal lasted less than a second. It chirped, it faded, but it was real, the first song of space-time. It was not loud, it was not beautiful in the way we often use that word, but it was true. And in that truth was a kind of wonder, that two things could collide so far away, so long ago, and that their meeting could ripple through the fabric of existence all the way to here. To us, to this small corner of Earth where mirrors and lasers were waiting. Since then we have heard more, black holes dancing and merging, neutron stars crashing in a final embrace. Each time spacetime sings, a low hum beneath the silence, a music that curves and stretches all things it touches. These waves do not need air, they do not need light, they are not blocked by walls or clouds. They travel through planets, through stars, through time itself. To detect them, we build instruments of incredible sensitivity, lasers that bounce across long tunnels, measuring distances smaller than atoms. It is like trying to hear the fall of a feather in a storm, but we have learned to listen, and each time we do, the universe becomes just a little less silent. These waves tell us what light cannot. They do not come from the surface of stars, but from their cores. They do not scatter or fade. They carry the shape of their source with them, the mass, the spin, the timing of the final spiral. In their patterns, we find fingerprints, identities, a cosmic signature drawn not with ink, but with curve and pulse. And it is not only collisions that sing. The entire universe hums with quiet waves from the very beginning of time. Some believe that when the universe was born, it rang like a bell, that the inflationary expansion sent out gravitational waves across the cosmos, waves still traveling, still humming through the black. If we can find them, we will hear the voice of the beginning. This is not poetry, it is physics, but sometimes they meet, because to imagine spacetime singing is not fantasy, it is recognition. Recognition that the universe is not only space and mass and speed, but rhythm. That time itself may have tempo. That gravity in its quiet persistence is not just a pull, but a pulse. Even now, there are binary stars circling one another in deep space, slowly drawing closer as they radiate away energy through these waves. Their orbits shrink not from friction, not from resistance, but from music. They are playing themselves into stillness. Imagine that two massive bodies in the dark, unseen by any eye, shaping the structure of the cosmos simply by existing together, by falling inward, by curving space so deeply that the curves begin to move. And those movements, those waves, pass through us, through trees, through oceans, through your chest as you sleep. Not harming, not stopping, just passing. We do not feel them. They are too soft, but they are real, and they remind us that we live not just in a place, but in a medium. That space is not empty. That time is not flat. That existence is a surface capable of rippling. And if space can ripple, it can carry information, not just where but how, not just distance but event. A black hole merger is not just something that happened, it is something that was sent, and now we are listening. Let us stay here for a moment longer, in the idea that the universe sings. That every spin, every collapse, every trembling orbit adds to the song. Let us imagine what it means to be surrounded by this music always, too low to hear, too slow to sense, but always there, folding softly through our world. And now let us go deeper, into the structure of the waves themselves, into the tools that catch them, into the moments where spacetime does not just move, but remembers. Let us follow the song a little further, and listen to what it is becoming. Let us now listen more closely, not with our ears but with imagination wide enough to hear the silent music of spacetime. Gravitational waves are unlike anything else. They are not vibrations of sound or light, but of the very fabric in which everything exists. When two massive bodies move in deep harmony, two black holes orbiting, two neutron stars closing in, they bend space itself. Not just a ripple on a surface, but a change in the shape of distance and duration. As these waves pass, they stretch everything, the space between atoms, the space between stars, not violently, but gently, almost shyly. These waves carry no charge. They cannot be reflected or absorbed in the way light can. They do not bounce off mirrors or scatter in clouds. They are pure curve, pure memory of mass in motion. They remind the universe where things have been and how they have moved, like footprints pressed into the shape of time. And because they pass through everything untouched and unweakened, they offer us a window unlike any other, a way to observe what light cannot show. Light tells us what something looks like. Gravitational waves tell us what something did. When LIGO first detected them, the world paused. Two black holes had collided over 1 billion years ago, and the memory of their meeting had just arrived. The detectors, built with astounding precision, registered a change in length smaller than a proton. It was a single soft chirp, the song of collapse. And in that chirp there was information: the masses of the black holes, the distance they had traveled, the speed of their union, the final silence after merger. This event was named GW150914. It was the first verse of a new kind of astronomy, one that does not rely on light but on touch, on the subtle trembling of spacetime. Since then we have recorded many more, each one a moment in cosmic history, each one a line in the quiet symphony of mass. To measure these waves, we use interferometers, long tunnels through which lasers bounce back and forth. When a gravitational wave passes through, the distances change. One arm lengthens slightly, the other shortens. The interference pattern shifts, and from that shift we draw a story that began long before life on Earth and only now has reached our senses. But the detectors are not just instruments. They are acts of faith in the quiet. They are places where humans choose to believe that the faintest murmur of space can be caught, recorded, and understood. And in that belief, we've found something extraordinary. The universe speaks in ways we never thought to listen for. It is not only black holes that sing. Neutron stars, those dense remnants of stellar death, also emit gravitational waves as they spin and wobble. Some of these stars are slightly misshapen, like a ball with a dimple, and as they rotate, their irregularities send out tiny waves. These are slow, steady notes, the long tones of cosmic bells. If we could hear them, they would hum beneath the sounds of the world, constant and true. One of the most remarkable discoveries came in 2017 when two neutron stars collided. The event was seen both in gravitational waves and in light. Telescopes across the world captured the flash, a kilonova, while the detectors caught the ripple. It was the first time we saw and heard the same event, a harmony of methods, a duet between curvature and color. And from it we learned that these collisions produce gold and platinum, the heaviest elements we treasure on Earth. It is humbling to know that the jewelry we wear, the circuits we build, the ancient metals buried in stone, were forged in moments so violent and distant, and that we can know this because spacetime sang. But not all waves are sudden. Some are long and slow, stretching across the entire sky. These are the waves from supermassive black holes, giants at the centers of galaxies, orbiting one another over millions of years. Their song is so low, so stretched, that it and not be caught in one moment. Instead, we listen through pulsars, rapidly spinning neutron stars whose radio signals tick like precise clocks. As gravitational waves pass between us and these pulsars, the timing shifts ever so slightly. By studying these changes across many pulsars, we begin to feel the long, deep rhythm of the universe's heaviest dance. This is called a pulsar timing array, a new kind of instrument made not from machines, but from stars. These ancient clocks, scattered across the galaxy, become our ears, and through them we sense a background hum, a low chorus of colliding giants, each wave carrying the weight of eons. Spacetime does not rush, it does not shout, but it never forgets. As we continue listening, we wonder what else we might hear. Could we catch the waves from cosmic strings, ancient scars in spacetime left from the early universe? Could we feel the tremble of inflation, the first expansion, the ringing of creation itself? These questions are not dreams, they are plans, and they remind us that even the softest voice can carry the oldest truth. Let us pause here in this knowing that we are surrounded by waves too soft to hear, too slow to touch, but real. That we are held not just by gravity, but by its memory. That we walk within a universe that does not simply move, but sings its movement into space. And now let us move to the final part of this journey. Let us imagine how this song continues, how it may shape the future, how it may carry the messages of stars not yet born. Let us follow this music to its quiet conclusion and see what it leaves behind. Let us now follow the final notes of this cosmic song, letting the rhythm carry us beyond the present, into futures both distant and soft. Gravitational waves do not fade quickly. They stretch endlessly, passing through galaxies and voids, their energy spreading ever thinner, yet never quite vanishing. Like echoes from a deep canyon, they may grow quiet, but their presence lingers. In this way, the universe remembers. Not with words, not with pictures, but with motion, quiet motion etched into spacetime itself. One day the stars will dim. The galaxies will drift so far apart that their light may no longer reach us. The night sky, once scattered with countless points, may grow empty. This future, slow and quiet, is not an ending in fire, but an exhale into stillness. Yet even then, gravitational waves will continue to move. Long after the last supernova, after the last fusion reaction fades, these waves will ripple through the dark, carrying the memory of everything that ever collided, ever merged, ever moved with enough grace and weight to bend space itself. In that distant era, spacetime will still sing, not loudly, not brightly, but faithfully. The song may be fainter, but its presence will be no less true. And in some way this reminds us that even when the visible ends, the invisible endures. That behind the story of stars lies the deeper story of presence and of change. Perhaps one day, long after us, someone else will listen. Perhaps another kind of life or another kind of intelligence will find these ripples and wonder who we were. Perhaps they will trace back the waves and read them as we now read fossils or starlight, as soft signatures of events long gone but not forgotten. Each gravitational wave is a page in that invisible record, a chapter written not in ink but in distortion, not preserved in stone but carried forward by the shape of space. A quiet testament that something once happened, that two giants spun around each other, or that a star collapsed into silence, or that the fabric of being rang like a bell. But even now in our moment, we are part of this music, not just as listeners but as participants. Our planet moves through the solar system moves through the galaxy, our galaxy moves through the cosmic web. All of these movements, small and large, combine into patterns, into rhythm, into breath. We are not separate from the song, we are chords in it. The gravity that shapes the curve of our spines is the same that binds moons to planets. The mass of our bones hums quietly in the music of motion. Every step we take bends spacetime, even if by the smallest amount. Every heartbeat is a tiny ripple. Every breath is a soft note. No part of us exists outside this field. We are woven into it, cradled by it. And that is what makes this song so powerful, not just that it reaches across time, but that it includes everything. Every galaxy, every collision, every orbit, every pause. The fabric of spacetime is not something we live upon. It is something we live within. Its movement is not other than our own. It is our own. There is comfort in knowing that the universe holds these memories so delicately, that the fall of two black holes, invisible to the eye, can still be heard. That silence is never truly silent. That stillness is never truly still. In every wave, you find a kind of grace that nothing is wasted, that no motion disappears. It may become quiet, it may fade from view, but it becomes part of the rhythm, and the rhythm continues. As we learn to listen more deeply, we will hear more. The next generations of detectors in space, in ice, in deep quiet places of Earth will catch fainter signals, longer songs. They will teach us to hear the universe not as chaos but as composition, not as noise but as meaning. And perhaps, in time, we will learn to add our own verses, not just by detecting but by understanding, not just by measuring but by belonging. So let us end this story not with silence, but with awareness that we are inside a music so vast and slow we must grow still to hear it. That space is not cold emptiness, but a resonant field, humming with the memory of all that ever was. You are part of that music. Your atoms came from stars that collapsed and sang their final notes in waves that now cross your body. You are made from echoes, and one day you will become one too, a note in the next great movement. This is spacetime singing to itself. This is the universe remembering through rhythm. This is the soft song of being. And it never ends. Before the first spark of starlight, before galaxies curled into spirals and nebulae began to glow, there were shadows. Not the absence of light, but something deeper, a kind of quiet, a waiting, a shape unfilled. These shadows were not darkness in the way we fear it, but form in the making. They were the outlines of space preparing to shine. And ever since, every light that has touched the universe has been shaped in part by its opposite. We think of light as the beginning of day, of life, of clarity. But light does not appear on its own. It travels, it bounces, it bends, and in bending it reveals what lies in its way. A rock becomes a silhouette. A mountain becomes a shape against the sky. A planet becomes a curve in motion. Shadows are not what light hides. They are what light discloses when it is met with matter. In the vastness of space, this interplay happens everywhere. Starlight strikes a planet and casts its shadow across a moon. A comet passes near a sun, its tail brightened by heat, its body dimmed by dust. Even Earth, suspended in space, creates an invisible shadow that stretches endlessly behind it, a cone of stillness in the streaming solar wind. But shadows are not always darkness. Sometimes they are coolness, like the brief relief of a cloud passing between you and the sun. Sometimes they are silence, like the night that follows a long day. Sometimes they are clarity, like the sharp edge of a solar eclipse when the moon perfectly blocks the sun, casting its small round shadow across the earth. In those fleeting minutes, the world darkens in midday, and we are reminded that even something so massive, so constant, can be covered, not erased, but gently veiled. At the heart of every eclipse, every shadow is alignment, the precise positioning of bodies in space. And that precision reveals a deeper truth. The universe moves in patterns, orbits match, paths intersect. Light travels in lines that are bent by gravity, caught by atmosphere, reshaped by reflection. And always, somewhere in that motion, a shadow forms, not randomly, not violently, but as a quiet result of presence. On Earth, shadows move with time. They mark the passage of the sun. They stretch long in the morning, shrink at noon, return in the evening like soft arms across the ground. Before clocks, shadows told us the hour. A stick in the ground could show the day's arc. A temple could measure the season by the angle of the sunbeam. Light and shadow together created time, not in numbers, but in rhythm. In the forests, animals follow shadows for cover. In the oceans, light fades with depth and shadows become shelter. In deserts, the smallest rock can offer relief from heat, not because it resists the sun, but because it interrupts its path. In this way, life grows in shadow, learns from shadow, rests in it. Even your body is a maker of shadow. Every movement you make displaces light. Every step you take leaves a temporary echo on the ground. A shade that mirrors your form, follows you without judgment, without need. It is always changing shape depending on the angle of the light. Tall in dawn, low in twilight, faint on cloudy days, sharp under midday sun. It does not speak, but it tells a story. It reminds you that presence always has a shape. In the sky, shadows are not only cast, they are also gathered. Dark nebulae float between stars, not glowing themselves but hiding what lies beyond. These clouds of gas and dust are the wombs of stars. Within them, gravity slowly gathers matter, compresses it, warms it until fusion begins and light is born. So the shadow is not the end of light, but its preparation, not its absence, but its cradle. Photographers know this, artists, dreamers, that light alone. E is not beauty, it is contrast that reveals. A face in sunlight has depth only because of shadow. A mountain at dusk becomes majestic because of the way the light folds around its edges. The cosmos is the same. Stars shine more brightly against the black. Planets shimmer more clearly near the dark limb. Even galaxies, with all their luminous arms, are more striking because they spin in night. And yet we often fear the dark. We fill our rooms with lamps. We light our cities against the night. But the night is not the enemy. It is the rest, the breath between sentences, the page between chapters. It is where our eyes can open inward, where silence becomes a kind of song. The deepest shadow in space is found near black holes, those places where light itself cannot escape. But even here the story is more than darkness. Around a black hole, matter glows as it falls inward, time stretches, light bends, shadows wrap back upon themselves, and in that strange geometry we see not an end but a transformation, a place where light changes, not disappears. Even your thoughts have shadows, the places you do not yet understand, the feelings that pass quietly beneath words, the memories that soften with time. They are not flaws, they are not failures, they are the spaces where new light may someday arrive. So let us rest in the idea that shadow is not separate from light, but part of it, that everything we see is shaped by both what is illuminated and what is not. That truth is often found not in the brightness, but in the contrast, and that behind every light some shadow quietly waits, not to hide, but to help define. And now let us move more deeply into this dance, into the places where gravity sculpts light into curves, where eclipses write temporary poetry across the sky, where shadow reveals the architecture of stars. Let us walk into the shade not as an end, but as a beginning. Let us now drift deeper into the quiet places where shadows help us see more clearly, not by revealing themselves, but by allowing light to form edges, boundaries, and meaning. In the cosmos, light travels endlessly unless something stands in its way. It does not stop. It does not hesitate. It moves in a straight path through vacuum, through gas, through fields of magnetism. But when it meets matter, a planet, a rock, a dust cloud, it changes. It reflects, refracts, bends. And in that bending, it creates the outlines we call shadow. This shaping of light is not an accident. It is part of how we understand the world. A beam of sunlight through a window becomes visible only because of the dust it passes through. A shaft of light in a dark room shows its path only when it is broken. And in space, the same thing happens on a grander scale. The shadow of a planet across a star can reveal the planet's size, its orbit, even the shape of its atmosphere. This is how we find exoplanets, not by seeing them directly, but by watching the dimming of light as they pass in front of their stars. A shadow tells the story. These transits are tiny events. A star dims by less than 1%, but with patience we read them like clockwork. Every shadow is a signal. Every dip in brightness is a path traced across time. We learn not just that something is there, but how it moves, what it's made of, and sometimes whether it might carry life, all from a momentary shadow. In another part of the sky, far beyond the reach of telescopes designed for light, there are shadows that fall on background radiation. Massive galaxy clusters bend the light from the early universe, and in doing so create subtle patterns. This bending, called gravitational lensing, is not just a trick of vision, it's a map. The mass of the cluster, including the dark matter we cannot see, warps the space around it, and the light from behind follows those curves. It arrives stretched, twisted, doubled. And from that distortion, we learn what cannot be seen. Sometimes a single background galaxy appears in multiple places, its light divided by the cluster's gravity. A shadow not of darkness, but of displacement. The original light is there, but the shape has changed. And from these changes, we measure the shape of space. These cosmic shadows do not hide, they reveal. They show us the curves of gravity, the presence of mass, the unseen structure of the universe. They are fingerprints pressed into spacetime, left not by touch, but by light's journey through distortion. Back on Earth, we experience this on a smaller scale. A sundial tells time because of the sun's shadow. A tree's shade cools the Earth because it blocks infrared light. A moonlit night is made possible by the Earth's shadow falling onto its surface, casting the planet into silhouette. Even the colors of sunrise and sunset, the deep orange and red, are shaped by the shadow of the Earth's atmosphere, scattering short wavelengths and letting the long ones pass through. So many of nature's most beautiful ents are not made by light alone, but by what light passes through or around. The gold that paints a mountain at dusk, the deepening blue as day fades, the halo of the moon during an eclipse, all are born from light softened by shadow. And sometimes shadow becomes metaphor, not just a shape on the ground, but a way of understanding, the shadow of doubt, the shadow of memory. These are not meant to frighten. They remind us that clarity does not require brightness. That understanding often grows in the places we have not yet fully lit. In ancient stories, shadow and light were often twins, not enemies, but halves of the same whole. The night was not a threat, but a time of quiet. The cave was not a trap, but a place of thought. And in the stars, constellations were drawn by tracing the darkness between the lights, not just the lights themselves. Even in physics, duality is everywhere. Light acts as both wave and particle. Matter behaves both solid and uncertain. And shadow, too, holds a kind of dual nature, not just absence, but presence. It is not the enemy of light, it is the companion. In eclipses, this companionship becomes art. When the moon perfectly covers the sun, it casts a shadow onto Earth, the umbra. Within it, day becomes night for just a few moments. The air cools, birds grow still, the world pauses, and then as quickly as it began, the sun returns. But something has changed, not just the sky, but us. To witness an eclipse is to be reminded that the universe moves with precision and grace, that our place within it is small and yet full of wonder. Scientists use eclipses to study the sun's corona, the faint outer atmosphere usually hidden by the bright glare. When the sun is covered, the corona becomes visible. In that shadow, new light is revealed. And so, once again, it is the interruption that teaches, the shadow that gives access. There are deeper shadows still, shadows cast by time. When we look at distant galaxies, we are seeing them not as they are, but as they were millions or billions of years ago. Their current shape, their present light, is still on its way. What we observe is their shadow in time, an echo of their past, arriving in the present. In this way, the universe itself is full of shadows, not of darkness, but of delay. Every star, every nebula, every flicker in the sky is a story told out of order. But the shadow reveals the path, the order behind the silence. Let us sit with this for a moment. That shadow is not something to avoid, but something to notice. That it frames our lives with rhythm, that it gives depth to our sight, that even in the brightest places, it walks alongside us quietly, giving form to the light we love. And now let us step toward the final part of this story, into the moments when light and shadow blur, where contrast becomes reflection, and where the softest darkness holds the gentlest truths. Let us complete this dance by seeing not just what is lit, but what it leans against to be seen. Now let us walk slowly through the final arc of this story, not to end it, but to let it settle. Light and shadow, we have seen, are not rivals, they are companions. The shadow helps the light become visible, and the light in turn gives the shadow its shape. Together they form a language not of words, but of presence, not of answers, but of balance. And nowhere is this balance more profound than in the cosmos, where vast spaces are filled with both brilliance and quiet. In the earliest days of the universe, there were no stars, no galaxies, no light, just a haze of particles drifting in heat and motion. This was called the cosmic dark age, not because something was wrong, but because light had not yet broken free. Photons bounced from one particle to the next, caught in a dense fog. There was no transparency, no direction, only waiting. Then over time, the universe expanded and cooled. Atoms formed, light decoupled, and the first shadows began not from darkness but from contrast. As stars were born, they lit up the void, and the places where their light could not reach became shadowed, not erased, not forgotten, just waiting their turn. These shadows are still visible in the cosmic microwave background, the faint afterglow of the Big Bang. Like an ancient photograph, it holds the earliest contrasts, the slight fluctuations that would grow into galaxies, clusters, planets, life. That faint map is not made of light alone. It is shaped by shadow, by the differences, by the quiet spaces between. This teaches us something gentle, something large. That creation did not begin in brightness. It began in stillness, and that the first thing the universe ever did was wait. It waited for the moment when light could move freely. It waited for shape, and from that waiting came everything. Even today, galaxies contain vast regions of darkness, not because they are empty, but because they are unknown. Dark matter surrounds stars like a soft H. Although holding them in place, guiding their paths but never shining, we do not see it directly, we feel its effect. We trace its presence through the motion of galaxies, the curve of gravitational lensing, the whisper of ancient radiation. It is shadow, yes, but it is also structure. Without it, the galaxies would fly apart. And between the galaxies, there is more stillness, the great cosmic voids, places where matter is rare, where silence reigns. But even these voids are not nothing. They are the stage on which light plays. They are the dark velvet that makes the stars seem bright. They are the places that give the universe depth. If the sky were filled with light in every direction, we would see nothing. It is the contrast, the distance, the separation that allows us to see stars at all. Shadow makes clarity possible. And so we return to Earth, where our shadows walk with us, not just on the ground, but within, in memory, in feeling, in the unspoken parts of thought. We carry both brightness and its outline. We are shaped by both. We need both, just as a photograph needs depth, and music needs pause, and stories need silence to breathe. In your own life, there are places where light cannot reach, questions unanswered, paths not taken, losses held close. These are not failures, they are part of the whole. The human heart does not shine by being full of only joy. It shines because it knows shadow too. It knows what has passed. It knows what has been quiet, and in that knowing it grows tender. When a forest is quiet in winter, it is not dead. It is preparing. When the sky darkens before dawn, it is not the end. It is the beginning. And when we sit in the shadow of something we do not yet understand, we are not lost. We are learning where the light will fall. So let this be a reminder. The next time you see a shadow, do not turn away. Look at the edge it draws, the shape it outlines, the calm it offers. Let it be not a closing, but a framing, not a silence, but a soft invitation. And remember, in the deepest part of a shadow, there is always the potential for light. Just as the eclipse ends with a burst, just as night folds into sunrise, just as understanding returns after a long pause. This is the gift of shadow. It teaches us to see. It teaches us to wait. It teaches us that contrast is not conflict, it is clarity. We live in a universe built on this dance. Light moves and shadow responds. Matter shines and emptiness shapes. Time flows and stillness gives it meaning. In the end, everything we love is framed by something else. The stars by the night, the sun by the moon, the self by its silence, and in that framing we do not find absence, we find beauty. So go gently, knowing you are held by both light and its echo, that your presence casts a shadow not because you are dark, but because you are here, and being here, fully and quietly, is the most luminous thing of all.